It's recording? Yes. Hello again. So this is the lesson for Friday, November 18th on stars. Okay, you'll have a classwork handout with star questions, and I'll explain how you use the reference table to answer those questions in a little bit. For now, let me just introduce stars. So I just came up with this PowerPoint. First, the basic definition for a star: it's a large body of gases that can produce, its own energy and is self-luminous. Okay, so it produces light on its own. Actually, let me go right to how do stars do that. So how are stars able to produce energy? They produce energy by going through this reaction called nuclear fusion. Hi, can you come over, please? That's nice.
Come over.
Okay. That's nice star glasses there. That's very appropriate.
Emmy.
Show your star glasses to the camera. Okay, quick. Hurry up, quick. Come on, look at the camera. Put your glasses on. Can you say hi?
Hi.
All right, that's nice. Now go over there. All right, so nuclear fusion is a reaction that's it's an explosive reaction, and that's what produces the energy for stars. For it to happen, it first needs conditions of high heat and pressure, and once those conditions are met, then it can take place. And what it actually is two hydrogen atoms, when they combine together, join together, they'll form a helium atom, and they can form a helium atom in this process, and that releases energy when that occurs. Okay? So, all right, just can you just, Emma, I'm just doing something here. I'm just upside.
Want to stay?
Yeah, okay, then stay over here. Okay. Okay, so let me just give you an example of a question that you might see dealing with the fusion type questions. So, thinking about nuclear fusion that I just explained to you, if you have this example of a star called star Z, just a hypothetical star, and it has 10% hydrogen and it's made of 90% helium, how old do you think that star is? Do you think it's relatively young or old? If it has mostly helium, let's go back to the reaction from the last slide. If it has mostly helium, that means that this process has been going on for a while. If only 10% of the remaining material is hydrogen, that means most of it has gone to helium. So it's an older star then. That was the answer. Okay. So there's a couple different types of stars that you're going to see on the reference tables. They're going to talk about main sequence stars, which are early stage, relatively younger stars. Then there's the giants or supergiants, and these are stars that are dying out, where the process of nuclear fusion is coming to an end. And then lastly, once the stars are totally dead and no more nuclear fusion is going on, then that would be the white dwarfs. Okay. And so how do stars like our sun, how do they evolve, and what stages do they go through? The stages would be, the first thing is when the star first forms, it's a contracting... Emma, go over there with Mommy, okay? It's a contracting cloud of cold gas, and then it initially becomes a main sequence. Remember I told you those are the early stage stars, when that nuclear fusion begins. When the fusion stops, our sun will most likely expand into a red giant, and then lastly, the fusion is going to stop and it'll turn into a white dwarf. So that's most likely the fate of our sun. Of course, that's going to take billions of years for that to happen, so there's no need to worry. Okay, I guess I could just quickly talk about what would happen if the star had a really large mass, which our sun doesn't have the high mass that's required to form a red supergiant. But that's what would happen. If you had a star with really high mass, when the fusion stops, it's going to expand and turn into a red supergiant. And then when this fusion completely stops, instead of turning into a white dwarf, like what's going to happen with our sun, Instead, it would explode and become what's called a supernova, and it would either become a neutron star or a black hole. So a black hole is like a tiny, dense point in space that has extreme gravity, and even light cannot escape because it's so dense and there's so much gravitational force. Okay, so that's just a quick lesson in the formation of stars. And now I want to show you a little bit about this diagram. This is actually the older one. Let me show you the brand new one that they have in the 2011 edition of the reference tables. It's a little bit different, not a whole lot. Okay, so let's see here. Can I just get this to show a little bit? Wait, wrong way. Okay. All right. So this is known as the HR diagram, and it shows us a couple of things about stars and how they're classified. We can see all the different types of stars that we mentioned. The main sequence stars, which you can see are represented by all these dots across here. The supergiants are all the way up there, giants, and the white dwarfs. And so the position of each of these little points is determined by the amount of luminosity. Okay, so how much light, the temperature of the star, and the color of the star. Okay, this has nothing to do, these little dots here have nothing to do with their physical position in the galaxy, okay, or in the universe. They're literally just points showing you about the characteristics of each type of star. Okay, so, and they have a couple of them where there's a little plus sign with a circle around it. That would be one particular star, and it's written in italicized print. Okay, so our sun is right there, so it's part of the main sequence, and notice they tell you here it's an early stage star. So you don't even have to memorize that, what I told you before about the main sequence being early. And then here they tell you the supergiants and giants are intermediate stage, and then eventually they will turn into late stage white dwarfs. Okay, so what other things is this graph telling us? Let's get a little more detailed here. The first thing, let's go to the luminosity here. So as you go up on the graph, okay, all these points that are higher up, they're much brighter. Okay, so the higher up you are, the more luminosity, the more brightness you have. And the lower you are, okay, thanks, Em. The lower you are, oh, you okay? The lower you are on the graph, the darker the star. Okay, notice that it's not going up by the same unit. For each interval, it's changing by a different amount. So from here to here, it's only changing by units of 1. But if you went from here to here, it's changing by units of 10. Okay, so that's the luminosity. Next we have, let's do temperature. So something that you should definitely take note of on this graph is that as you go to the right, the temperature is actually decreasing. It's not what you'd expect on a graph. Usually numbers are increasing as you go to the right, but for this graph, it's decreasing. Okay, and these numbers are in Kelvin. Okay. Color, so it tells you the relative color for each area on the graph. So the sun, you can see, is here by the yellow classification. All right, and then the last thing we have here is the relative mass of the stars. Notice the higher up you go, the more mass of the stars. Hence the name supergiants or giants for these stars located high on the graph. Okay. Look, Beetlejuice.
Yeah.
Okay. Got it. Beetlejuice. Yeah. So let's see. What else do I want to tell you about that? I think that might be it. Well, this is the classwork handout I'm going to give you for tomorrow. And let me see here. I think what I said there pretty much explains it. It's self-explanatory. But I might ask you a question like, what kind of star is Procyon B? And you would say that it's a white dwarf. Or what color is Procyon B? And you go down here and it's white. Okay, or what's the relative temperature of Procyon B? So, okay, this is 8,000 K here. That's 10,000, and that means that this will be 9,000. So Procyon B is a little bit less than 9,000. Maybe we'll see like 8,600 K, something like that. Let's see, what else do I want to show you? Another example. How about, maybe I'll ask you a question, which is brighter, Sirius or Alpha Centauri? And since Sirius is higher, it's going to have greater luminosity and therefore it's brighter than Alpha Centauri. So those are just a couple of examples of questions. Alright, good luck tomorrow, and I'll see you for the next video to go over the stuff for Monday. Okay, we're almost done with this unit actually. I hope you've been following along with all these video lessons, and you should go back and review them and look through your classwork. A bunch of them I went over the classwork handouts too, so you should check the answers on that. Okay, bye-bye. Goodbye.